Hello everyone, I'm Yuanrui from Zhejiang University. I'm glad to present our IMZ paper, What Makes a Popular Academic AI Repository. As noted by Nosek et al., transparency, openness, and reproducibility are crucial features of science. We notice that in the AI area, researchers are encouraged or even required to publish data, software code, and other resources that accompany their papers. And AI studies often use GitHub repositories to share such resources. In this work, we define GitHub repositories that accompany AI publications as academic AI repositories. Many previous studies have noted that GitHub provides the starring feature, and the number of stars can reflect the popularity of a repository. Popularity of an academic AI repository can be an indicator that the corresponding paper attracts great interest. So, in our work, we set out to investigate the characteristics of popular academic AI repositories as compared to unpopular ones. By doing so, we provide suggestions to help AI researchers improve their academic AI repositories. We investigate the distribution of the number of stars, the relationship between paper citations and the popularity of academic AI repositories, and the SE practices of popular academic AI repositories. We mainly focused on analyzing the SE practices of popular academic AI repositories. By doing so, we provide actionable suggestions for AI researchers. Our experiment setup is as follows. First, we collect academic AI repositories from GitHub, and we collect citations of corresponding papers from Google Scholar. In our preliminary study, we analyzed the distribution of the number of stars and the corresponding correlation between the paper citation and the number of stars. Then, we label the collected repositories as popular and unpopular, and extract features to characterize the SE practices of the repositories. Based on the labels and features, we answer two research questions. Are popular and unpopular academic AI repositories statistically significantly different? What are the most important features that distinguish the two groups of repositories? We collect academic AI repositories based on a GitHub repository named Papers with Code. This repository lists 1,448 papers with code. However, we notice that not all of the listed repositories are created by original paper authors. We performed two steps to clean the data. First, we check if the README file contains words like our work or our paper. Secondly, we compare each of the paper author's name and each of contributor's name. Finally, we collect 1,149 academic AI repositories. Our preliminary study shows that the number of stars is high good. Only a small proportion of academic repositories have a large number of stars. We also found that highly cited papers are likely to have popular academic AI repositories, and vice versa. Then, we analyze the SE practices of popular academic AI repositories. We label top 20% repositories that have the most number of stars as the popular academic AI repositories, and we label bottom 70% repositories as unpopular ones. We extract repository features from three dimensions: code, reproducibility, and text. In total, we collected 1,030 labeled academic AI repositories and extracted 21 repository features. Our code is shared in our accompanying repository. Based on the labeled repositories and our features, we analyze the relationship between each SE practices and the popularity of academic AI repositories. We leverage Wilkinson's rank sum test, chi-square test, and CLIPS delta to compare popular and unpopular academic AI results repositories. As a result, we found that in terms of 11 features, popular and unpopular academic AI repositories are significantly different. We found that popular academic AI repositories contain more code files, code lines, and models. They take more measures to ease the reproducibility, and they have more organized documentation and provide more detailed information. We leverage the random forest to analyze the important features that distinguish popular and unpopular academic AI repositories. We found that the most important features include the number of links to other GitHub repositories in the README file, the number of images in the README file, and the inclusion of a license. We also have several interesting findings. We compare personal and organizational academic AI repositories. We found that the organizational repositories are more popular. Personal and organizational academic AI repositories are different concerning the relationship between SE practices and the popularity of repositories. We also found that there is no significant association between paper topics and popularity of academic AI repositories. We also observed two categories of images in the README file of academic AI repositories, including running results of the code and the working mechanism of the code. Both types of images are positively correlated with the number of stars of an academic AI repository. In summary, we analyzed the characteristics of popular academic AI repositories as compared to unpopular ones. In total, we analyzed 21 repository features along 3 dimensions, including code, reproducibility, and text. We found that in terms of 11 features, popular and unpopular academic AI repositories are significantly different. We also analyzed the important features that distinguish popular and unpopular academic AI repositories. Thank you.
Hello, everybody. Welcome again to the Open Science session. My name is Sira Vegas, and I am the session chair. Today we have is with us Yuanrui Fan, and he's going to answer all questions you may have. Okay, so we have here a few questions. So I think we can start with the first one. Okay, Yuanrui. So the first question has been asked by Said Siddiq, and the question is: how do you distinguish a repository as academic AI or not?
So we collect our academic AI repositories based on a GitHub repository called Papers with Code. This is shown in our presentation, and we found that this repository lists over 1,000 repositories that are linked to AI papers, such as ICML and ICML and NIPS. So this, but in some repositories, out of these repositories, we found that some of the repositories are not owned by the paper authors. We filter that repositories, and we only label the repositories that are owned by the paper authors as the academic AI repositories.
Okay, thank you very much. So let's move on to the next question that has been asked by Elib Babi. Is there a correlation between the popularity and the code quality amount of technical debt?
This is a good question. However, we did not investigate the correlation between the popularity and the amount of technical debt. We have published the code repositories in our accompany repository. So researchers are encouraged to find whether there is a correlation.
Okay, good, thank you. David Benavides is asking, why did you consider only GitHub but not other repositories like Zenodo, for example?
This is because the easiness of the collection of the repositories. We accidentally found the papers with code repositories that have listed a large amount of academic AI repositories. So it is convenient for us to analyze it. It is also encouraged for other researchers to find those academic repositories from Zenodo and replicate our study. Yes.
Okay, thank you. Another question from Yashin Rao. Do popular AI repository get frequent pull requests? If yes, what is the quality of those pull requests?
It is true that the popular AI academic repositories get frequent pull requests, but the frequency is not such as such number as the many other popular repositories such as OpenStack and other Linux such as Linux. These repositories are very professional, and only professional people can submit such pull requests. But in our study, we did not analyze the quality of those pull requests, and it is also encouraged for the researchers to analyze those pull requests.
Okay, so thank you very much. Yeah, there's one question that just popped up. What about the other GitHub features of a project? So, for example, number of watches or number of forks. Do you consider this?
We have analyzed the number of forks of the academic AI repositories, and we found that they are highly correlated with the number of stars and the number of citations in the Google Scholar citations. And so this is also this is consistent with our findings about the number of stars with the citations. And we did not analyze the number of virtues. So
yes, please continue. Okay, did you finish with the answer, or do you want to add something else?
Maybe this is this can be explained by the theory of the searching engines, such that in the Google, many the pages that are linked by many pages and link many other pages are very popular. So in GitHub, such a repository is also a GitHub page. So this may be an explanation, and it can be further. It can be further investigated.
Okay, thank you very much. So there's one more question. So Xiaoyu Sang is asking, is there any reason for the feature about the link to another GitHub repository? it is really interesting.
Yes.
So is there any reason for the feature about the link to another GitHub repository?
Some popular repositories are, for example, some popular repositories can link the repositories that are also popular. For example, a popular repository can link a repository can link a repository that also has how many good code and many professional people. So in this for this repository, they may be more popular.
Okay, thank you. Another question. Bo Yang is asking, what suggestions can your research bring to us as researchers?
So in our study, we found that the most important features that distinguish the popular and unpopular academic repositories is that the documentation is about the documentation. That is, popular academic AI repositories write more organized documentation, and they provide more detailed information in their documentation. So we recommend to the researchers to write more organized documentation and provide detailed information, and for example, write more lists, provide more images, and so on, to make their repositories more much more easier to be used.
Okay, thank you very much. One more question. So Feng Kai Wen is asking, do you think those features may have a similar impact on all types of academic repositories?
In our study, we analyzed some features that are related to AI papers. So, for example, whether the repository provides a model, and whether the repository provides the data and some other things. So these features may only be related to those AI papers, but for some other features, such as documentation features and code features, these features are also general for other types of academic repositories and academic papers. Future studies are encouraged. We encourage future studies to analyze the correlation between these features and some other types of academic repositories.
Okay, thank you. We are done. Let's move on to the next